Okay, hello everyone. My talk is titled Creator Secondhand, but I probably wouldn't be able to explain this title not until the very end of my talk, so I ask you to wait a little bit for it. Now I'm going to give you some introduction on what I'm going to talk about, and that will be, first of all, I'm going to give some general questions, general points about electricity and gravity in space and what we can probably explain with the help of electromagnetism. And then I'm going to give you a couple of theories by Pavel Mantashyan on alternative to dark matter and formation of the solar system. And then I'm going to give you a promised conclusion about the title of my talk and what's the point of my talk in general, okay? So now, since I've mentioned Pavel Mantashyan, I'm going to say a couple of words about him. He's an inventor, an author of more than 60 inventions, 4 books, and 30 articles. But since they are in Russian, I don't give any names here. It's actually that we've never met in person. It's that I read his books and I really like them, and since I already was into electric universe stuff at that time, we've agreed that I will come here and give a talk because Pavel Mantashyan cannot give a talk in English. So it ended up like that, okay? Now, we've never met in person, as I mentioned, because he lives in Russia, but I live in Belarus, and maybe some of you might wonder where it is, so I'm going to show you. Here's the map of Europe with my country, and it just so happens that Immanuel Velikovsky was born in Belarus. He was born in Vitebsk, a couple of 100 kilometers from where I was born and where I live in Minsk. And okay, so that's kind of where it all started, right? And so at the right, you can see our national flag, and I wouldn't put it here if it weren't for this vertical band that you can see on the left. This is a really archaic piece of ornament, and I might be a bit paranoid, but it looks kind of like Parad's Squatterman or something like that, okay? So I'll just give you this bait, so maybe you would come and search more info about my country. Okay, since I've shown you where Belarus is, I'm going to ask you where we are in terms of theories and ideas and hypotheses. And of course, if you look at modern astrophysics, you would find that it is pretty much dominated by gravity, okay? So we kind of have this huge thing of gravity and only a thin layer of everything else on the top of it, okay? So just like Don Scott have quoted that if there is electromagnetism, well, it probably doesn't do anything, okay? It's just a decoration of sorts. And so there's a principle of charge neutrality of cosmic objects, whether it is explicitly stated or implicitly kind of being there, okay, which states that there are no electric currents, there is no net charge separation, etc., etc. But when people try to kind of use this worldview to describe the real data that we have from observations, they get kind of odd results, and in order to fit those results into the hypotheses and theories, they have to invent some sort of crutches or I don't know, even peg legs maybe, those artificial things like dark matter and dark energy and many, many other things. Well, I'm going to talk about dark matter a little bit later, but I just want to note about the dark energy that when people say that universe is expanding or the space is expanding, in my opinion, this is a logically incoherent statement. Well, if you say that the ether is expanding, well, that's okay with me. I find it a good idea, but the universe cannot expand. If you try to define all the notions really carefully, you would find that this is a logically incoherent statement. But if you want to discuss this, please contact me. I don't have much time to discuss it here, okay? So, since we kind of know where we are now, where can we go from here, okay? So we can suggest or hypothesize that there is charge separation and electric currents in space, and maybe that would allow us to throw out all of these crutches and go along on our own feet, okay? So maybe we should hypothesize that electromagnetism plays a major role alongside gravity in the universe. And so the central hypothesis of the proposed theory by Pavel Mantashyan, and I'm going to reinstate it a little bit later, is that electric charges do exist in space, and he says that they exist actually on stars, okay? And now some general points that I've promised on electromagnetism. I here listed a field of applications of electromagnetism, of possible applications, okay? Now, magnetic fields in space, I'm pretty sure that you are aware that almost every object in the universe possesses at least some sort of magnetic field associated with it, whether it is an induced magnetic field, like for example, on Venus, or it is an intrinsic magnetic field, like in the bar magnets or on Earth, etc., etc. And if you take a look at Maxwell's equations, you would find that the magnetic field actually arises wherever we have a changing electric field. And a changing electric field means that we have a motion of the source of electric field. And the source of electric field are charged particles. And when we move charged particles, we get electric currents. So there's a pretty much straightforward connection between the electric currents and the magnetic fields. So if we acknowledge the existence of electric currents, thus we can explain the existence of magnetic fields. It's as simple as that, okay? Now, solar wind acceleration, I'm pretty sure that you're aware that the fast solar wind that's coming out of the coronal holes is getting accelerated like from 3 solar radii to up to 10 solar radii, from 350 to up to 800 kilometers per second. And the slow solar wind also gets an acceleration of around 100 kilometers per second. And so, how can we explain this acceleration? Well, the most simple idea that can be probably out there is to suppose that really the sun possesses some electric charge. And this electric charge just accelerates these protons of the solar wind outwards by simple electrostatics, okay? Of course, in real life, so to speak, there would be complications with certain plasma effects like Debye screening and maybe some other things, but I think it's a good start to start from here, okay? Now, sunspots formation, I've noted here that there's a theory by Pavel Mantashyan about how vortices form in general. Unfortunately, I cannot give many details on this, but just in a couple of words, the theory states, well, basically that the motion of charged particles in a magnetic field creates the rotation of these particles due to a Lorentz force. And if we have a big quantity of such particles, they start building up angular momentum in this field, and thus due to fluid dynamics, the whole system starts to rotate. And that's how we get these vortices, like, for example, tornadoes or cyclones or anticyclones on Earth, or eddies in the ocean, or gyres. And that's basically what is a sunspot from the Mantashyan's theory. And, of course, Ben Davidson has his theory of Earth spots, and this is pretty much it, in my opinion. Okay? So in sunspots, the charged particles on the surface of the sun move in the magnetic field of the sun and build up this angular momentum and create this vortex, the circular current, essentially. And this current, because the particles are charged, creates the magnetic field of its own, and we get essentially the sunspot. Okay, so that's one of the ways of explaining it. Now, lensing, I'm pretty sure that all of you have heard about the gravitational lensing, right? But you might ask, what's so gravitational about it? Okay, so maybe there is another explanation. I think at the previous EU conference, there was Edward Dowdy talking about this, about the refraction of the light in plasma, actually, and not due to gravitation. And I think that this is a good idea, that plasma really can refract the light in principle, in theory. I'm not saying that it really is doing that, but we might suppose that it is doing that. And so this interstellar plasma and plasma around galaxies might actually refract the light and act as a lens. But more than that, I want to add here that we have an electro-optical effects like Pockels effect and Kerr effect that actually amplify the refractive index of matter due to electricity. So if we have an electric field applied to this plasma, the refractive index might be bigger than in sort of an ambient plasma, and we might get stronger lensing. This is also an interesting possibility, in my opinion. Okay, solar system formation, I'm going to talk about this later, and differential rotation too. Galactic rotation curves, that's where the dark matter comes in, okay? Now, on the left, you can see this picture where we have the velocities of stars or molecular clouds or whatever else plotted versus the distance from the center of galaxy. Okay, and so we can notice that somewhere around the middle of the spiral arm, or maybe somewhere closer to the core, we get this discrepancy between the measured velocity and the velocity that we can calculate through Newtonian gravity and Keplerian motion. Okay, and if we look at the bottom to the right, we can see that the measured velocities are getting much higher than what we can calculate. And on the bottom of the right, you can see the simplified form of the second Newton's law. And what it states basically is that the square of the velocity is proportional to force, okay? And what does that mean? That means if we have an excess velocity, then we should have some excess force that we cannot account for, okay? And so people are thinking, okay, if we have only gravitational force in space, that means that we have some extra gravitation that we cannot account for. And since we all love our gravitational constant and want to keep it constant, probably, right? Then it means that we have extra matter, extra mass that we don't see. And that's how the dark matter was invented. But maybe there is another explanation to it. Let's remember what I've said about the magnetic fields. Everything possesses some sort of magnetic field. So let's take a look at magnetic fields of galaxies. Now on the left, you can see a view of a really oversimplified view of a spiral galaxy as viewed from, for example, the northern side and the southern side. And thus the plane of picture coincides with the plane of galaxy, okay? And these arrows, they depict the direction of the magnetic fields. And we have this picture that, for example, on the northern side of the spiral arm, the fields are directed to the core from the ends of the spiral arms, okay? And on the south, we get the opposite direction. And so in general, it creates the picture of sort of wrapping around, sort of a Berkeley current, but with the other geometry, okay? Okay, and on the right, we can see another component of the magnetic field of galaxy. It is a dipolar type field. L is the distance from the plane of galaxy. So kind of imagine that the vertical line is a plane of galaxy, and if we're moving northwards where L increases, the field starts rising and then it starts falling off like a field of a bar magnet. And to the southern side, we get the same picture, but the sign is inverted, okay? So these are kind of a basic components of the magnetic fields of galaxy. Of course, the real magnetic field of galaxy looks much more complex, and I'm going to show it to you how it should look like, okay? This is the data from ESA Planck mission, of course. What we see here is the direction of polarization of electromagnetic radiation, which supposedly coincides with the magnetic field lines, and the color depicts the intensity of light, which is proportional to the density of matter, okay? So we really can see that we have these magnetic field lines going along the spiral arms in the plane of galaxy, and we also have this dome-shaped bar magnet type field around it to the both sides of the plane of galaxy, okay? So how can we create such magnetic field? I told you that the electric current is the most simple way of creating a magnetic field, okay? So here's this hypothesis again reinstated, that stars have an electric charge, okay? And let's take a look. Maybe we can create these magnetic fields with this hypothesis, okay? So here on the left, we again see one of the spiral arms with a piece of a core of galaxy from both sides. And on the right, we can see a slice of this spiral arm along this red curved line. So it's kind of, we are observing the array of stars moving along their orbits kind of in parallel, but they move on us or from us. That really doesn't matter, okay? So let's suppose that these stars have a positive electric charge. This is, it's pretty much arbitrary thing, but we should at least make some supposition about it. Okay, let's suppose it's positive, and the stars move outwards from us into the plane of picture. That would mean that they create the circular magnetic field that is actually clockwise directed, right? Each star creates a magnetic field of its own. But if we sum the magnetic fields from each star, we would get this wavy pattern, okay? Going, for example, at the northern side, it goes to the right, and at the southern side, to the left, okay? So we get really this picture of magnetic field lines going in one direction at the northern side and returning at the southern side. So we get this sort of a wrapping around thing, okay? I think this is pretty simple and pretty elegant, but let's think about this. Let's think how would these fields act on the stars themselves, because the stars as electric currents should be, I mean, the magnetic field should act on these stars because the stars are electric currents, okay, if they move. And so we can apply the left-hand rule, for example. The four fingers show us the direction of motion of a positive charge, which is in the plane of picture, and magnetic field lines enter the palm of our hand. Then the thumb would show us the direction of the Lorentz force that is acting on the northern stars. It would be directed southwards. And for the stars on the southern side, it would be directed northwards. So what we get is that the spiral arm gets squeezed. Again, the same type of behavior as with Birkeland current filaments, okay? But the geometry is different. And in my opinion, this is one of the explanations of why the galaxies are so flat. Why do they have this pancake-shaped form, okay? But let's think about another thing. How would these currents, I mean the stars, interact with each other? The parallel currents, as we know, they attract. This is called the Ampere's law. And this is actually how the definition of ampere as a unit of electric current is defined through this attraction, okay? So this would be, of course, the different component of a magnetic field, the vertical one, but still, they would attract. And how would this attraction look like in the middle of the spiral arm in radial terms? In the middle of the spiral arm, we would get pretty much the same quantity of stars closer to the core and closer to the rim. So we would be attracted in both sides with pretty much the same force, and it will compensate, okay? But when we are moving closer to the rim outwards from the core, the quantity of stars closer to the core would increase, and the quantity of stars closer to the rim would decrease, and we would have this excess attraction to the core. And here on the left, for example, you can see, again, this is a really simplified version of this graph. This is an Ampere's force. R is the difference from the distance from the core, excuse me. And at some distance, you can see that the force is zero, but if we are getting closer to the rim, we are getting attracted to the core. And this kind of gives us really this unaccounted for force, which people explain with dark matter. Okay, and on the right, we can see the sum of this force with the gravitational force, the 1/r squared. It gets a little rise at the ends of the spiral arm, okay? And that can, in principle, this might explain the excess force that we need, okay? So that would mean that we don't need dark matter, actually, okay? So this is one theory, and another theory, of course, there are questions because for example, closer to the core, we would have the force that drags us to the rim. But I'll leave these questions. This is a sort of a second-order problems. I'm getting the principal theory, and I think it really might account for what we observe. Okay. Now, about the solar system formation, there are, of course, a lot of models, a lot of theories, but they all face the same difficulty, which is explaining the angular momentum of the system. Why is it rotating? And the angular momentum is a sort of a measure of this rotation. If we look at the expression, it says that we should take a sum over all the particles that we have, and we should take a product of their masses, their distances from the axis of rotation, and their velocities. So the more massive particles we have, the farther out they are from the axis of rotation, and the faster they go around, the more angular momentum we would have, okay? And the solar system actually possesses quite a big angular momentum. Of course, everything is relative. Here, but the important point here is that the angular momentum should conserve in a closed system. So if we had, for example, a nebula that did not rotate, and it, for example, would condense by gravitation, it wouldn't start rotating on its own. It would need some external driver to make it, to spin it up, okay? In the solar system, the angular momentum is mostly due to Jupiter, okay? And if we take all of the giant planets, they have like 99% of the angular momentum. As I've said, we need to have some external driver, and pretty much in gravitational paradigm, the only driver is probably the passing star. So maybe if some object had passed nearby the solar system, it may have spin it up, like wind blowing to the windmill makes its wheel spin, okay? But is there another explanation? Mantashyan proposes actually another explanation, and it again centers on the Lorentz force. So, if we had an external magnetic field, like for example a galactic magnetic field, and if we had charged particles, if the planets and the sun were charged, they actually might get this angular momentum due to interaction with this external magnetic field of galaxy. And here's another hypothesis explicitly stated, that during its formation, the solar system was exposed to a powerful galactic magnetic field, which was perpendicular to the ecliptic plane. Now, I must note here that we don't actually need to have an ecliptic plane here. What we need is only the charged sun that is moving in this magnetic field. And with the I'll try to show later how the charged sun moving in a magnetic field can get its rotation. That's when it get the equatorial plane, and the ecliptic plane would pretty much coincide with the equatorial plane. But in this model, the planets are being born by the sun itself. They are being ejected out of the sun. So let's suppose that young, active, and electrically charged sun ejects some plasma in space filled with galactic magnetic field. Those would probably be like today's coronal mass ejections, but much more massive and basically and much more intense. And those were the protoplanets ejected out of the sun. So I ask a question: what conditions should be met for this plasma to turn into a real planet? And the answer is that we should eject from the equatorial plane. Because, well, think about the launch of the artificial satellites from Earth. We need to launch them from the equator if we need to get the same orbital direction like the spin of the Earth, okay? Because that's how Earth helps us with its own rotation. It gives us additional velocity, additional energy, and additional angular momentum too. And thus, the external magnetic field that I've mentioned would provide the most angular momentum, and that's what I'm going to illustrate right now. Now, on the left, we can see a view from the side of the sun ejecting some piece of plasma somewhere a bit northwards, okay? B is the magnetic field lines of galaxy. The lines of the magnetic field of galaxy. V is the velocity of this piece of plasma, and the Lorentz force would be directed into the plane of picture if we suppose the positive charge, okay? So the Lorentz force would be equal to QVB sine alpha. Now, Q is the charge of this ball of plasma, V is its velocity, as I've said, and B is the magnetic field strength. Now, alpha is the angle between the velocity vector and the vector of the magnetic field. So if we look at it, when would the Lorentz force be maximal? It would be maximal when we have the sine alpha equals to unit. That would be when the alpha, when the angle would be perpendicular, when the velocity would be perpendicular to the magnetic field, and that would be at the ecliptic plane, in the equatorial plane of the sun. Okay, why would we need this Lorentz force? Again, think about how the satellites are launched. They do not fly straight up, okay? They fly straight up to a certain height, and then they start tilting the rocket and kind of fly up, and then they are flying sideways, so they get this circular orbit, okay? Because if you fly straight up, what would happen is that upon the return to the Earth at the perigee, you might be too close to the Earth. You might actually fall down to the Earth, okay? So that's what we need, this kind of sideways force that draws us to the side. And here the Lorentz force plays the role of such force. And the Lorentz force provides us the circular orbits, okay? So when we are launched, on the right you can see the view from the North Pole of the Sun. Here is this piece of plasma being launched, and then it goes sideways due to the Lorentz force, okay? And kind of upon the next approach to the Sun, it wouldn't be too close to the Sun. It might survive, actually. And the Lorentz force would help to build up angular momentum of the system and make its orbit, to expand its orbit, make it more circular over time, okay? So I've promised to explain how the spin actually being acquired. So the same story would be, actually be for the sun and the planets. So I'm going to talk only about the sun today, right now. And on the right, you can see a schematic of the sun. We have the rigid solid body core, presumably. Okay, now by this point, I'm pretty sure that you've noticed that I'm a little obsessed with red color, right? So we have this rigid core, then we have this liquid layer on top of it, if we are to believe Pierre-Marie Robitaille, okay, then we have a charged surface layer where the charge of the sun is situated, okay? So when the thing moves in the magnetic field of galaxy, what happens is that the charged particles, again, they start rotating due to Lorentz force. And this rotation builds up angular momentum, and due to liquid dynamics, the whole charged surface layer starts rotating, okay? And what that would mean that due to friction, the liquid layer would start rotating, okay? And then the core would start rotating, and we get the magnetic field eventually, okay? So that's how, in this theory, the rotation was acquired by the sun and by the planets later. Okay, and I've promised to explain how the differential rotation might appear. Now, if you take a look at these horizontal lines in the liquid layer, I've drawn them there for a reason. You might notice that in the equatorial region, actually, the thickness of this liquid layer is the smallest. And as we get closer to the poles, it increases. And so it would be kind of easier for this liquid layer to rotate in the equatorial region, and it might get a bigger velocity there. And thus, we can, in principle, explain the differential rotation of the sun and giant planets, okay? So what factors would be at play in this rotation? The rotation would be the more intense, the more electric charge we've had, okay? So we need to be big and carry enough electric charge. That's first of all, and then the charge might be diminished by the solar wind or another CMEs or anything like that, okay? So we need to be as far from the sun as possible to avoid the diminishing of the blowing off of charge due to the solar wind from this charged surface layer, okay? So the farther out we are from the sun and the bigger we are, the more rotation we would get, okay? So that would mean that the giant planets should spin the fastest in the solar system. And guess what? We get, actually, that's what we observe now. Jupiter, take a look at this. This is the biggest planet, and it has the lowest spin period, the smallest, which is somewhat ridiculous, isn't it? And so the Jupiter was really big. It had a lot of electric charge, and it's relatively far out, okay? Saturn was a bit smaller, but it was also farther out, so this relative solar wind density was smaller at the orbit of Saturn, and is to this day, okay? And the same story with Uranus and Neptune, pretty much. And with the other planets, now, of course, there are concerns about Venus and stuff, but I'm not going to talk about this right now, okay? So now, what about these young planets? When they are still hot in plasma, but they are already rotating and have their magnetic fields, why wouldn't they eject some piece of plasma of their own? That might be possible, and actually Mantashyan thinks that it's what was really happening, okay? And so that's how the satellites might have been formed. They might have been ejected out of the planets and gained their angular momentum and their circular orbits in the magnetic field of the mother planet, so to speak. Okay, so what characteristics should they possess for us to say that really they were born in such a way? Well, first of all, they should have low eccentricity, low inclinations, so they should be pretty much in the equatorial plane of the mother planet, because I've shown you before why would that be. And also, they should have low eccentricities because Lorentz force gives us circular orbits. And also, they should have the same direction of rotation because they were launched from the planet itself. Now, I mean, the same as the spin of the planet. Now, I'm pretty sure that you know that there are a lot of satellites that do not possess these characteristics, okay? So how could they form? Well, standard theory says that they are probably the captured bodies. Well, it might be that, but in Mantashyan's theory, another explanation is possible, is that these satellites actually are kind of brothers of the planet. So they might have been born out of the same ejection that gave birth to the planet itself. Maybe there was not a uniform piece of plasma going around, but maybe there were some additional splashes or something like that. Or maybe there were several pieces of plasma, some of them merged, and some of them was small, but they've somehow managed to survive, and they could have formed all of these so-called irregular satellites, okay? This is a possibility. Now, let's take a look at some examples. Jupiter, pretty much all of the inner satellites, including the Galilean, the most massive ones, have a low inclination and low eccentricity. So in this theory, they were actually born by Jupiter itself, okay? And the outer moons, like starting from 9th, they have a pretty high inclinations and eccentricities, and starting from 16, they have retrograde orbits, so they orbit in the opposite direction, okay? So we get this picture. So they are probably either the brothers of Jupiter or they are captured bodies, okay? Now, if we're talking Velikovsky, by the way, I just want to note that maybe if Venus was actually born out of Jupiter, maybe it was from the big red spot where it was born, okay? But this is just a thought. Now, Saturn, the same story as with Jupiter, but the Titan, of course, dominates the whole system, and it has also a low inclination, low eccentricity, so it probably was born from Saturn, okay? In the first 24 moons, they too have the low inclination and low eccentricity. And the outer moons mostly have retrograde orbits, very inclined, and eccentric orbits. So they are probably either the brothers of Saturn or they were captured bodies. Now, the same story with Uranus, but the important exception is that the equatorial plane of Uranus is very inclined. It's almost perpendicular to the ecliptic. So Mantashyan thinks that what happened is that when Uranus had its spin and magnetic field, its orbit, its spin axis was inclined due to some reason. I don't know what the reason might be, maybe a collision, maybe something else, and that's when it started to give birth to its satellites that we observe today, because the inclinations are with relative the modern equatorial plane, which is highly inclined, okay? Now, what about Neptune? We get this moon Triton, which is really big, and it moves in a highly inclined and retrograde orbit. So under this theory, it probably was born out of the same ejection, so it's kind of a brother of Neptune, okay? And the other moons possess kind of the same qualities that are for the other giant planets. Now, important thing, Mars and Earth. Okay, Phobos and Deimos have little inclination and little eccentricity, so they were probably born out of Mars, under this theory at least. Of course, there are other hypotheses. Now, the Moon, what's interesting, it has a relatively high inclination, high eccentricity, so it couldn't have been born out of the Earth, probably, and it also has a lot of mass. It's more than 1% of mass of the Earth, and it is a unique case in our system. And as Mr. Thornhill have noted yesterday, I think, that actually the Sun pulls the Moon more than 2 times stronger than the Earth pulls the Moon. So actually, the Moon is going around the Sun. It's not orbiting the Earth. The Moon is sort of a sister planet for the Earth. And the orbit of the Moon, you can see on the right, that's what the orbit of the Moon might look like, as you might think it looked like. Yes, but I've crossed it out because this is wrong. The orbit of the Moon around the Sun is elliptical. It never does these curls around the Earth, okay? It's elliptical. It, of course, has little waves because of the perturbations of the Earth, but in general, it moves around the Sun, not around the Earth. So the Moon is a quasi-satellite of Earth, and this is one of the pieces of evidence for this theory, I think. You can Google what a quasi-satellite means and compare this to this elliptic orbit around the Sun. Okay, so I'm close to the end. The points in favor of the proposed model is the relatively high angular momentum that we can explain with this external field, the existence of the ecliptic plane, the circularity of orbits due to the Lorentz force, the spin characteristics of planets, this is a really interesting point. And so the red-colored ones, they actually cannot be explained through only an accretion, okay? We should have something else to it. Of course, there are questions now. Where did this magnetic field go? How strong it was? Where did the charges go? Whether it just withered away because of the sun or something else? There are a lot of questions, I admit. And I think, for example, if we suppose that the magnetic field suddenly changed or even depolarized to the opposite, there might have been this epoch of instability and catastrophes because the Lorentz force would change and the orbits would suddenly change, and there might have been all of these catastrophes with charge exchange and electric discharges and everything else. So this is kind of a point where we can dock this into a more traditional, so to speak, electric universe theories, okay? Now, if we look at the sun and the galaxy, what we can see, this is what Mantashyan calls the Matryoshka model, or a Russian doll model, as you might call it, okay? The idea is that the satellites were once embedded in planets, and the planets were embedded in the sun, and the sun was probably embedded in the galactic core or something, so it might have been ejected from the galactic core one day, and the galactic core might have been ejected from somewhere else, like a supercluster core, and it all happened in the magnetic fields of larger and larger scale, okay? So we get this really fractal structure of things kind of evolving and differentiating on a smaller and smaller scale. We get this Herbert Spencer type evolution. And here the Lorentz force plays a role of universal transformer of this linear motion into circular rotation. And in my opinion, this is one of the explanations for the ubiquitous character of the circular rotation in our universe. Because in gravitational field alone, you would have an arbitrary eccentricity. You wouldn't have exactly the circular orbits. Well, we don't have exactly the circular orbits, but they are too frequent, in my opinion, to form by accident. Okay, so this is what I've promised to you. In order to understand the universe, we need to observe the work of both hands of the Creator, the gravity and electromagnetism. So if we focus on only one of those, we lose perspective and kind of perceive the world with only one eye out of two that the nature gave us. So I hope that it really explains the title of my talk, because we should have this linear gravitational attraction and this Lorentzian thing that gives us really all of those structures that we observe. Okay, you were a beautiful audience. Thank you for your patience. Thank you for your attention.